so let's talk mathematical operations. All of the mathematical operations you would expect to have are included in Julia, so you can add, subtract, multiply, divide. And here's the syntax for that. So we're printing out a bunch of math operations, all of them pretty self-explanatory. This is division. You're going to get what you expect there, which is 2. This is 11 integer divide 24. So it's not going to do any decimal places because these are 2 integers and we're doing integer divide. It will give you 2 for this, and this will give you 3. So this is division with remainder, if you remember that. This remainder will be used fairly frequently, and I will talk about that when we get to it later. So you can take a number to a power. You can compare 2 numbers, so you can do greater than or equal to. This is what's called a Boolean result. It's true or false. So I could flip this and ask if 2 is less than 1, and it will give us false. So all those numbers are what you expect. Play around with adding, subtracting, multiplying. You're going to be doing plenty of that throughout the semester. You want to make sure you get comfortable with that. Okay, so now we can do a function. So just like in math, we can have functions that take in numbers and give back numbers. Here we have that same kind of thing happening. So we have function square root number. So it is a function that takes in a number, and it's going to give you the square root of that number. No surprise when we run this, the square root of 16 is 6. And then we did a function of a function. So functions can take functions as their arguments. So what this is really doing is it's evaluating this operation, this function call, passing the value that it got to this. So it's square root of 16 is 4, and then doing the operation again, square root of 4 is 2. This is something that you probably don't want to do a lot of nesting functions like this. Normally you're going to save it to what's called a variable, and we will talk about variables right now. So everything we've done so far has just been calling functions or doing operations and printing the results. Sometimes you want to store the result and use it later in your code. So how you can do that is by using a variable. And all variables have a type. So just like all the numbers we were using up there, they implicitly have types. So all the integers we were using that didn't have a decimal place after them are integers. So these are whole numbers. And then there are decimal numbers called floating point numbers. You don't need to worry exactly what that means. It just has to do with how it's stored on a computer. So a lot of numbers, a lot of operations in Julia don't care if it's a float and or a floating point or an integer. You can use them together. So I could make this 1 and it would just work just fine, and it'd still be a float. So now it'll be negative 9.2. So those are numbers. So other types of variables are called Booleans. So these can only take true and false values. So like we did above with this 2 greater than 1, 2 less than 1, it can only be true or false. These are extremely important because they're used all the time for what's called control flow, which we will talk about here in a second. One thing you can do with almost any type of object, actually any type of object, is any type, any variable, is do what's called equality comparison or value comparison. So what this statement is saying is we're going to assign a Boolean variable to are they equal, corresponding to whether or not 12 is equal to 3 times 4. So equal is the syntax for comparison. Equal, one single equal, is assignment. Equal is checking whether or not they are equal. So don't get confused by that. Equal is assignment. Equal is comparison. So we can also check this string here. I didn't mean to do that. Sorry about that. Let me click out of that. Whatever. So our string's equal, so these two strings are not the same, so this will be false. So when we print this code, we get true and false. This is one thing you'll want to know. You can clear the outputs. You can clear all of the outputs for the whole file with that. So I right-clicked Okay, doesn't want to run. Oh, there we go. You can clear just the output right there if you want to just clear a single output. Just a word for the wise. And I guess while I'm on the topic of weird, quirky things with JupyterLab, and I'm going to send a link to a tutorial of how, if you want to dive deeper into how to use this JupyterLab, that's optional to watch. But one thing to watch out for is if you let this sit idle for a long time, this whole environment will go away and you'll lose your work. So if you're going to step away from your computer or think about something for a while, I highly recommend downloading your file that you're working on. That way you don't lose your work. It'd be really frustrating if you lose your work because this is kind of a temporary environment. And I will show, if for those that want to learn how to use this stuff on their own computer, then that way you're never going to lose your work as long as something bad doesn't happen to your computer. But yeah, that's a digression. So here's that statement again about comparison. So if you need to refer back to it, this is the statement that tells you equal versus equal equal. So similar to how we did not equal, we have just the value of not, or sorry, the operation not, and it can take any Boolean value and flips it to the opposite value. So what we're doing here, my value, my Boolean is true, printing it, flipping the value to false, printing it again, so we've called it not my Boolean because that's what it is, it's not true, and then we're doing it again and it'll come back out as false, sorry, true, false, true. So if you do not twice, it's the same as x, and if you do not 3 times, it's the same as 1 not. So even and odd nots always result in either not doing it, not having done the not at all, so you get the same value, or just doing 1 not. So here's an example function. We're going to combine some of the things we're doing and introduce a couple of different things. So one thing you'll notice here is I'm declaring specifically here what kind of thing this is, what type this is. This is good practice to describe what type of variable it is. Julia allows you to just go through all of your code and not do it. And sometimes it is correct to not include one of these. But generally speaking, throughout most programming languages, this is either required or implicitly done. Julia is a little bit more dynamic, and it will try to figure out what to do with 2 different things. So if you're working with floats and ints, it tries to figure it out. So we've defined specifically what our input variable, it has to be an integer. Both float and integer are of type number. So this function would work equivalently if I just put number here. So I'm going to go ahead and run it like this just to make sure. Yeah, so it's the same thing. So you'll see when I put it back to this. But sometimes you want to explicitly say that this has to be, an integer. So we have a couple of Booleans. The fact that I like ice cream, which is true. 2 is bigger than 1. That's always true. So we are going to, I don't think I'm even using this, so that's okay. And we have an unused value. Maybe pretend that later on in the code we're going to use the fact that 2 is greater than 1. Let's just do it. Print ln is 2 greater than 1. And then I think I might have introduced this before. What I'm doing here is called string interpolation. So this will, that's probably the wrong syntax. I have it down here below. It's a $sign with, that's the syntax for a different language. When you learn more than one language, sometimes you mix your languages together and do something wrong. So another example of syntax has to be exact or it will fail. So moving on. So variable names, and I've mentioned stuff about this, and I will continue to mention things like this of best practices in code that you want to learn early on. You always want to name variables something meaningful. So address is better than input string because it tells you what the input string that you're using is. It's an address. The worst is just using a single letter variable names. You'll see this in a lot of what's often called, it's a code smell. Means something's not right, indicative that the code wasn't well written or potentially has errors. A great book on coding style is Clean Code by Robert C. Martin. Kind of more of an intermediate textbook, but if you find yourself kind of getting past the beginnings and you want to dive deeper into programming, especially object-oriented programming, and I'll talk about what object-oriented means later. His resources, his YouTube videos online, anything from him is a great resource to use. A quick summary on my thoughts will be in the software engineering page on the programming tutorial website, and I'll be updating that periodically throughout the semester with more pages and content. Alright, so we talked about Boolean variables, and where they're really useful is what's called control flow. So here's the syntax for doing a conditional statement. So right here, if 2 is greater than 1, we are going to execute this code, and if it isn't, we won't execute this code. 2 is always printed because 2 is always greater than 1, which is true. I'm going to make this a variable 2 greater than 1. One thing I might not have mentioned earlier is that a variable name or a function name can't have spaces in it, so that's why you'll either see things like underscores to separate words. Sometimes you'll see what's called camel case, so like 2 greater than 1 equals 2 greater than 1. There's a lot of different ways to do it, and there's different languages have different style guides of ways you're supposed to name variables. I believe Julia, you're supposed to use underscores like this. So this is the same thing. It's a Boolean variable. You can put a statement that will result in a Boolean here, like we did with 2 greater than 1, or you can put a Boolean value. You can't put just like a string here. You shouldn't be able to. It might figure this out. No. So this is a non-Boolean type. So in some languages, if you were to put this, if 1, because true is stored as a 1 on the computer, that works in some languages, but not Julia. So you would have to do something like that. Anyway, lots of different things you can do with an if, but it has to be a Boolean statement. Anyway, moving on. So now let's do a function. So the rest of an if statement is the else. So implicitly in this one, we have an else of do nothing. Below, we have a function that will do something else, and this was my first typo. When you get an item price, so we have a imaginary store that sells one item and potentially gives a discount. So you pass in true or false whether or not you want the discount. If you give a discount, it will return 70% of the item price, else it will return item price. So when we do false, we're going to get the normal item price, and we do true, pass true, we get the discounted price. So that's how an if-else block works. And we're going to have a more complicated example down at the bottom that uses a lot of if statements that you can play around with. Boolean operations and logic. So Booleans have operations that we can use on them. So we've already seen equality and inequality and not. There's also what's called and or. So they will take what's on the left and right of those operations and or. And then we have all these examples of here of all the permutations of this, where you will get a Boolean variable back. So and you have to have true and true to get true. So I will just run all of these. I'll let you read them. I think they're fairly self-explanatory. So and you have to have both, or is either one is true and you get true back. This is false or false. There was my second typo. This will be updated before you guys look at it, but run through this, read through all these, make sure you understand what's happening, and then I'm going to pause 1 second. Okay, and I'm going to type one more that will help see this a little bit. So I'm not going to print the string. I'm just going to do 2 greater than 1, or let's do it the other way. 2 less than 1, or A equal A. So what do you guys think this is going to print out? So it printed out true. So if either one of these is true, the resulting value is true. So that's what OR does, and give us false, as we expect. So let me go ahead and erase that. You might see I'm not actually pressing this play button every time. If you hit Shift Enter, it will run the code that's in that block. It's a little neat shortcut. So here's an example of running with an if and an else. So all of these are the same. I'm going to jump through this really quickly, and then I'm going to let you guys read through it and play around with it and understand it. So it takes a function that takes in 2 arguments or inputs, both of them strings. It's going to do some checking of whether or not things are equal to other things, and then return a string. So notice here that assignment operator, where we were specifying the type, a function, we're specifying what this function is going to return in this, because we're using this return statement. We've done it before and we've done implicit stuff, so we didn't explicitly use it. It's important to do this to let the other programmers and other people using the code, or let yourself know, your future self, because you will forget the code that you wrote many days ago. So knowing how to use it, writing good code isn't just for other people, it's for yourself, because you are other people to the person who's writing code now, is the way I like to think about it. So we're printing different messages. So what I wanted to show with this block of code is that the AND operation with ifs is the same as nesting an if inside an if. So this might be easier to read. If name is Jackson, go into this if statement, and then if email address equals my email address, return the message that we defined above. And also notice that all these blocks, everything in Julia, I may not have mentioned this, kind of has starting syntax and an end block. So if ends, so they should all align with each other. So this if, you know that this if goes with this end because it's aligned with each other. So back to this, these 2 statements are equivalent, so read through it, make sure that you understand why those are equivalent. And is like nesting. So or, this one is similar, but the names are different. So if Joe or email address Joe Chem, I know, and then print the name of the person. This is somewhat equivalent, so if, else if, print the exact same thing. So normally you would want to do it more like this one. This is the better syntax, because you only had to write this line of code once, where you've duplicated. Another thing to know about this code is this is not good practice to have this line 3 times. It's the exact same code. You should write a function that just returns that and takes name as its parameter. One adage, wise words that I've heard is essentially if you're copying and pasting, you're probably doing something wrong. The only time you should be copying and pasting is to move code out into a function so that it can be used repeatedly. Not explicitly true, because sometimes you copy and paste and you edit something, but if you copy and paste something and you're just leaving it almost the exact same, you're doing something wrong. So I'll let you play around with this. I'll print out all of these just so you can see them. So play around with this example, change some of the values, change things to get a feel for this. So that's the end of this module. So the only thing you need to do for this, there's no explicit exercises to do for this. The exercise is just to make sure that you can use this Jupyter notebook and run all the things in it, so all the code blocks. So once you've run all the code blocks, the output will be there, and then you can go ahead and save it, and then download it, and then change it to make sure that your name is in the file. Like so, last name Hayes, first initial J, and then 0 intro. This extension is Jupyter, and then upload that to Canvas in the place that was instructed in the Canvas page. All right, with that, I will end this first tutorial. Thanks for listening. I hope it was enjoyable and or informative, and hope to see you guys continue through and learning this.